Hi everyone. So actually the last session, the session number 3, so it got terminated, okay, due to some internet connectivity. Okay, so this is a part 2 of session 3. Okay, so you can watch session 3 and after that you can watch this. Okay, so this is the session 3 part 2. Okay, session 3 link you can find in the description. All the digital logic standard question sessions, you can find the playlist link in the description. Okay, so you can check. Now let's continue from where we left in the last in the session number 3 part 1. Okay, so we were discussing this question. In this question you can notice a k-map is given to you, but this k-map is not standard. You can notice the k-map. If you look at the k-map, then this is not in the standard format. The standard format of k-map is this 00011110. This is the standard format of k-map, but you can notice that this k-map is not in the standard format and this function is given to you. So this is the k-map for function f a comma b comma c, and we have to find what is the minimized expression of f. But remember, this k-map is not in the standard format. So first you notice what information you can find from this k-map. So from this k-map we can find the value of function for all the combinations of variable. Okay, for all the combinations of a comma b comma c, we can find the value of function f from this k-map. For example, if I ask you what is the value of this function for example, if I ask you what is the value of this function for 4, means for 100, for this 100, what is the value of this function? Very simple, 100, and the function is fabc. This is your function fabc. Okay, so for this 100 means ab is 10, ab is 10, c is 0. Okay, so you can notice your function value is 0, ab is 0, ab is 10, c is 0. So finally I can say that your function value is 0. So this information you can find from this k-map. Okay, now remember one thing. When you see this k-map, please don't do this, like, okay, please don't do this, please don't do this. This is wrong. If you do this, this is wrong. For example, if you directly do this, this is wrong. Why? What is the reason? The reason you can notice here, the reason is given k-map is not a standard k-map. This is not in the standard format. Okay, because you can notice 00110110, this is not in the standard format. So first you convert this into standard format. This is the given k-map. Okay, for this k-map, what you do, you find the standard k-map. Okay, you convert this into standard k-map, so your standard k-map is like this: 000011110. This is the standard k-map. Now tell me, so you can notice 000, so this will be 0. Next, 001, that is 1, there is no problem. Now notice this row. Okay, look at this row 01, look at this row 01. So this row will go here 10. Yes or no? Very simple. See, very simple. This is the row 0101. Okay, and this is your 01. So finally I can say that this row will go here. I can say 10. Next you can notice, look at this row. Look at this row 11. So this is 11, and this is 01, this is 01. So both are 0101. So finally this row will go here. Okay. So finally you will get this row here. And next 10 is same. Okay, next 10 is same. So first you convert into standard truth table, standard k-map, then you solve. Okay, now you can do like this. Okay, so what will be your answer? Now you can do. Okay, so we want minimized expression, so now you can do this. So tell me what you are getting here. In this, what you will get this. Okay, so you can just check it out. So here, this is the area, this is the area of a, because here a is 1. This is the area of b, because here b is 1, and this is the area of c, because c is 1. So I can say that this is in the area of c, in the area of a bar, sorry, in the area of b bar, in the area of c, in the area of b bar. And notice, where is this, in which area is this? Okay, so this is in the area of, look at this is in the area of b and area of c bar. So your final answer will be what? Your final answer will be cb bar or bc bar. This will be your final answer. Okay, so like this you can find. Is this clear to everyone? Okay, so quite simple. So like this. Now remember one thing, one more thing. And so remember, there are two ways to represent, two standard ways of to represent k-map. Two standard ways, these are the standard ways to represent K map, if you want to represent K map, then there are two standard ways to represent K map. So either you can represent like this. See, the K map, either you can represent like this, that this is your K map. Okay, so let's assume, for example, this is the K map. Okay, let's assume this is variable a, b, c. Now either you can represent like this, 0 1 0 0 0 1 1 1 1 0. This is one way. Okay, like this if you write, okay, like this if you write, this is one way. There is another way. There is, I can say, this is your way 1, this is one way. And what is way 2? Okay, some authors, there are some authors, there are some standard resources which use this map, this representation. They use this representation to represent K-map. They don't write this code. See, they don't write this code. What they will write, very simple. What they will write, they will write like this. See, here a is 1, right? Here a is 1. So you can notice here a is 1. So they will write like this, that this is the area of A. This is the area of A. Like this they will write. Okay, like this they will write that this is the area of A. Basically, it simply means that this is here A is 1. It simply means here A is 1. You can notice here A is 1. Okay. Next, here you can notice, B is 1. Can you notice B is 1? Here B is 1. Okay. So they will write like this, that here B is 1. Okay. And you can notice here C is 1. Here C is 1. So they will write like this, that here C is 1. So these are the two representations. Is this clear? But remember, they will not write, they will simply write A, B, C. Okay, so it simply means that here A is 1, here B is 1, here A is 1, here B is 1, and here C is 1. So either they can give you this representation or they can give you this representation. Both are standard. In the standard resources, both these representations are given. Okay, so you can find both these representations. Now, another representation for the same. See, you can think like this, very simple. They can give you like this. So this is the area of B, because this is the area of B anyway. So this is the area of B anyway. This is the area of A, and this is the area of C. Okay, so like this. So these are the two ways. Anyway, both are same. There is no problem. So this is the area of A, this is the area of B, and this is the area of C. I can say, or I can say that here A is 1, because you can notice here A is 1. Look at this. A is 1. So here A is 1, and here B is 1. Okay, so like this. This is the representation. So these are the two standard ways of representing K-map. So you can check. Okay, so you can check. This is from Cambridge University, let me tell you. And this is the same thing is followed by NPTEL Professor Indranil Sengupta. They also follow this same template. So basically you cannot, this is Z. Z means, because this is XYZ. XYZ. So here X is 1, and you can notice here Z is 1, and you can notice here Y is 1. Okay, so like this. This is the representation of K-map. Now let's solve this question. This is a GATE exam question. What is the answer for this? This is GATE 1998 question. The K-map is given to you. Is this the standard format? This K-map. So tell me, can I do like this? Okay, the question is asking the function that is represented by this K-map. So can I do this? Just tell me, just can I do this? If I do this, then what answer I will get? Can I do this? Okay, can I do this? What answer I will get? I will get B bar. Okay, you might be thinking, I will get B bar. Is this correct? This is not correct. This is not correct, because remember, this is not in the standard order. Okay, this K-map is not in standard order. So this is not correct. Okay, the reason, let me tell you the reason. The reason is that given K-map is not in the standard order. Okay, given K-map not in standard order. So first you convert this into standard order. So this is what you are going to do. Just convert this into standard order. So let's convert. Okay, so you will make a K-map. Just make this K-map and you find this in the standard order. Very simple. So this is variable A, variable B, C, and this is fine. This A 0, 1, this is fine. But you make this in the standard order 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so now you can fill this row. You can fill like this. Remember, this is the 1, 1 row. This is the 1, 1 row, and 0, 1. This is the order. 1, 1 row, 0, 1. So this same thing you can put here. And next, this 1, 0 row you can put here, and the remaining is same, 1, 1, 0, 0. Now what will be the answer? Now the answer is very simple. Okay, so you will create this one. You will create this one. Okay, so now the answer is quite simple. You can, one more thing, one more thing. This is the area of what? Like this is the area of, this is the area of what? This is the area of, you can notice this is the area of B. Okay, this is the area of B. So this is the area of B. And what is, this is the area of what? This one. Okay, like this one. This is the area of what? This is the area of C. And this is the area of A. Okay, so finally your answer will be like this, that you can capture this, and this will be in the area of B in the area of C. Next, you can capture this. Next, you can capture this one. This is in the area of B bar, and this is in the area of C bar. So your final answer will be, your function is BC or B bar C bar, and the final answer is B XOR C. B XOR C, or I can say that B XOR C complement. B XOR C complement. Okay, so this will be the answer. B XOR C complement. Okay, answer is option C. Is it clear? So in the GATE exam, they can give you this type of non-standard K-map they can give you. And now, very interesting question from the Cambridge University. This is the question from Cambridge University. Okay, so this K-map is given to you, and they are asking, okay, so many questions you can solve in this K-map. First of all, in this question, they are saying that this K-map is given, and we have to find the minimized expression. So find the minimized expression of FABC. Minimized expression of FABC. Let's find minimized SOP expression of FABC. So what you will do? This is in the standard K-map. Can I say? Can I say this is in the standard format? This K-map. This K-map is not in the standard format. Okay, because see, very simple. If you write like this is the B, A, comma, C. Definitely this is not in the standard format, because in the standard format, this is the area of A. This is the area of C, that is fine. But in the standard format, this is the area of A. So this is not in the standard format. I can say, okay, actually if you notice this K-map, if you notice this K-map, this is same as like this. Okay, this K-map, if you notice, this is same as this. This K-map is same as A, comma, C, comma, B. And what encoding is given to you? 1, 0. Remember, the coding that is given to you, that is given like this. Because this is the area of B. This is B, means B is 1 here. See what this B means. Tell me what this A means. What this A means. This A means that here means that here A is 1. Here A is 1. And this means here C is 1. Here C is 1. Okay, and this means here B is 1. Here B is 1. So you can notice here B is 1. And here here you can notice this is C. This C is 1 here. And A is 1 and C is 1. A is 1, C is 1. And here A is 1. So you can see like this. Here A is 1, C is 1. Here A is 1, C is 0. Okay. Next, you can notice here A is 0, C is 1. And here both are 0. So this is the encoding. Is this clear? This is the encoding given to you. Tell me. So basically, what is this encoding? In this, what is this encoding? This encoding is 10110100 and G10. So this is the encoding that is given to you. And this is not the standard. I can say this is not the standard K-map. Tell me, did you understand this? This is a very nice question from the Cambridge University. So you can check. Okay. So very simple question. Basically, again here, remember this A means here A is 1. This B means here B is 1. And here C is 1. And this unspecified means, okay, that this is don't care. Unspecified means don't care. Okay. So basically these min-terms are don't care. These are don't cares. Unspecified means don't care. So finally, this K-map is given to you, and we have to convert this K-map into the standard K-map. What we will do? First, we will convert this B, A, comma, C, okay, 1, comma, 0, and this is given as 1, 0, 1, 1, 0, 1, 0, 0. Okay, this is given to you. First, you converted this into the standard K-map that we know. just convert into the standard K map. Okay, into the standard K map. So into the standard K map, if you do, then this is a, okay, first you will write, remember, 0 here, 1 here. You will write 0 here, 1 here, then 0 0 0 1 1 1 1 0. So what will be the standard K map for this? And this is given to you already. This is given to you as, so these are 1. So you can notice these are 1, these are 1, and these two are 0, these two are 0, and these are don't care, don't care, don't care. Okay, now you do this mapping. So what will be 0 0 0? Tell me what will be, like, okay, remember this is ACB. So what will be 0 0 0? So the 0 0 0, that is 1, that is 1. AC, remember here ACB, the function you can think like this. You can think the function as ACB. You can think like this. Okay, so this will be 1. Tell me what this will be. Tell me what this will be. Did you understand why this is 1? Because you can notice when ACB, when this is 0 0 0, then what is the function value? When ACB, when that is 0 0 0, then the function value is 1. Next, when ACB is 0 0 1, when ACB, that is 0 0 1, okay, then your function value is 0. Next, when ACB is 0 1 0, when ACB is 0 1 0 0 1 0, then your function value is 1. When your ACB is 0 1 0, then the function value is 1. And here function value is don't care. Next, 1 1. So this will be don't care 1, and next 1 0. Okay, so 1 0, that will be don't care 0. So this will be your standard K map. Now once you have the standard K map, now you can find the answer very easily. So just tell me what is this area. In this area you can notice this is the area of C. Here C is 1. Okay, here C is 1. So this is the area of C. And you can notice this is the area of A, and this is the area of B. Now you can find the minimized expression. So what will be the minimized expression? We need to cover ones. We need minimized SOP. So minimized SOP we want. So we need to cover ones. So you can cover this one. Okay, you can take this one. This one will be B bar. If you take this one, then this will be B bar. And if you take this one, okay, then this will give you, okay, this will be C. So your final answer F will be what? Your final answer F will be C or B bar. This will be your final answer. Okay, C or B bar. Is this clear? C or B bar. To how many people is this question clear? Very simple. See, this is the GATE exam question we have already done. Okay, this is a GATE exam question, but this is a Cambridge University question. Very nice question. Okay, the K-map that is given to you, that is not a standard K-map. So first you have to convert this into the standard K-map. Okay. Debanjan, basically your answer should be correct. Okay, so this is the standard order. We are comfortable with the standard order. So that is it is good. If you don't want to make any mistake, then always follow the standard order, because we are very comfortable with the standard order. Yes or no, Debanjan? It does not matter. See, this 0 1 1 0 you can solve. If this same order you take, that also fine, Debanjan. If you take this 1 0 order, that is also fine. But anyway, you can take this order because we are comfortable with this standard order. But you can solve the question. If you have, like, if you have 1 0, then also you can solve the question. If you have 1 here, 0 here, then also very easily you can do the question. Okay, so you can note this is the complete question. Actually, this is not the complete question. This is just a part of it. The complete question is this. What this question is saying, read this. A number of Boolean function conform means obey. So this is your verbal ability. I am improving your verbal ability. This means obey. The meaning is obey. Okay, so a number of Boolean functions, they obey the K-map. Tell me how many Boolean functions they obey this K-map. How many? What is the meaning of this line? This line is saying that a number of Boolean functions obey this K-map. What is the meaning of this line? Tell me. A number of Boolean functions obey this K-map. What is the meaning of this? The meaning is very simple. Because of these don't cares. Remember, there are 3 don't cares. So it simply means that, okay, there are total 8 functions will have this k-map. 8 functions will have this k-map. I can say 2 power 3. 2 power 3 equal to 8 functions have this k-map. Functions have this same k-map. Because remember, there are 3 don't cares. So you can notice this is a don't care, don't care, don't care. And for every don't care, the function value can be 0 or 1. So in your function, whenever there are don't care, it simply means that you have a class of functions. Okay, whenever you have don't care, the presence of don't care means that you have a class of functions. So there are total 8 functions which have this same, I can say, which follow this, which obey this k-map. Is it clear? Very simple. Okay, whenever in your function, if you don't care, if you have at least one don't care, then your function is a family of function. I can say family, or I can say class of functions. And the number of functions in that family, that will be 2 power number of don't cares. Like here you have 3 don't cares. So there are total, I can say there are total 8 functions in this, which have this k-map. Now this is asking, tell me, the question is asking, okay, first you find minimum SOP, that we have already done. Now the question is asking, find a function which is of 2 variable. What this means? Tell me what this means. The question is asking, find a function. Total 8 functions are there. Total 8 functions are there. Find a function which is of 2 variables. Means one variable is dummy. Can you notice what this means? What this means? Tell me. This means that one variable is dummy. It simply means that one variable is dummy. Correct? One variable is a dummy. Okay, so you look at this and tell me which variable can never be dummy. See, these are the don't cares, but tell me which variable can never be dummy. Look at this k-map and tell me which variable is never dummy. This is my question. Okay, in this you tell me which variable is never dummy. Which variable can never be dummy? Cannot be dummy. There are, okay, forget about don't cares, because total 8 functions are there. Okay, it simply means there are total 8 functions are there, but in all these 8 functions, which variable can never be dummy? In these 8 functions, total 8 functions are there. In these 8 functions, which variable cannot be dummy? Which variable cannot be dummy? Tell me. You can check that this variable c can never be dummy. Variable c, the answer is variable c. The answer is variable c. The variable c can never be dummy. See, why the variable c can never be dummy? Because if you notice, if you change the variable c, keep everything as it is, keep everything as it is, just change the variable c. Can I say keep everything as it is? Can I say ABC and ABC bar? If you change the variable c, then you can notice this will not happen. This will not happen. Or I can say that, okay, I can say that this, okay, this is not true. This is not true. This is not always true. This is not true, because you can notice, if you just look at these two, okay, just look at these two. Here, tell me what is here. Here you have a b c bar, c. Here you have a b c, and here you have what? Here you have what? Here you have a b c bar. Okay, so you can notice that your function value f for your function value f for one, for ABC, for 111, your function value for 7, that is your function value for 7, that is 1, and your function value for 110, your function value for 110, that is 0. So definitely I can say that C is not dummy. Definitely C cannot be dummy. Is this clear? C cannot be dummy. Tell me, is it possible that A can be dummy? Can A be dummy? Okay, this is my question. Can A be dummy? Can you make A dummy? Can A be dummy? Can you make A dummy? Can we make A dummy? Okay, just try to make A dummy. A dummy means, remember what this means? This means that if you change the A, keeping everything same, it simply means that if you change A, but remember, keep everything else same. Keep everything else same. If you change a, then if you change a, then will your, like, okay, just make sure that your function does not change. Just change a, keep everything else same. Then can I make a dummy? So here you can notice here, this is 0. So sorry, this is 1. Yes, I can make it 1. See, I can make it 1. There is no problem. I can make it 1 because here you can notice in this cell, look at this cell. So this cell is A, B, C, and look at this cell. This cell is A bar, B, C. So yes, I can make them same. Next, okay, next you can notice here there is 0. Here there is 0. What is this? This is A, B, C bar, A, B, C bar. Okay, now what is A bar, B, C bar? Where is A bar, B, C bar? This is A bar, B, C bar. This is A bar, B, C bar. So yes, I can, this is already 0. This is already 0. Okay, next. So are you getting my point? So you can notice, and here both are 1, 1. So what is this? This one. This one is A bar, B bar, C bar. This is A bar, B bar, C bar. And what is this? This is A bar. Okay, so what is, where is A, B bar, C bar? Where is A, B bar, C bar? So this is where you have A, B bar, C bar. So yes, I can make it 1. Yes, I can make it 1, right? I can make it 1. Okay, I can make it 1. And then finally, I can make this one also. Okay, I can make this one also because this is your A bar, C, A bar, B bar, C. This is your A bar, B bar, C. And you can notice this is your A, B bar, C. So yes, can A be dummy? The answer is yes. A can be dummy. Yes or no? Did you understand this? Remember the definition of dummy variable. Please understand the definition of dummy variable. Dummy variable says, what is a dummy variable? I can say if this happens, like, okay, you keep everything else same. Okay, you keep everything else same. Just change this. Keep everything else same. Just change this. If you change B and still, then it simply means that B is dummy. In this situation, I will say that B is a dummy. This is the definition of dummy variable. And if B is dummy, then this will happen. So what I am saying that C cannot be dummy. You can check because, okay, C, this variable C, this cannot be dummy because already this is a 1, this is 0, and you can notice here you have ABC, here you have ABC bar. So we are changing C. We are changing C and the function value is also changing. You are changing C. This C you are changing. Everything else is same. Everything else is same. Okay, you are changing this C. But function value is also changing. So I can say this C cannot be dummy. Okay, so C cannot be dummy. Definitely C is not dummy. Next, can A be dummy? Yes, you can make A dummy. A you can make dummy. Okay, if you want, you can make A dummy. Can you make B dummy? Tell me. My question, can B be dummy? Is it possible that can B be dummy? Can B be dummy? Can you make B dummy? Okay, so check it. Can you make B dummy? Already remember this is 0, 0. Okay, so can you make B dummy? Means keep everything else same. Keep everything else same. Just change B. Only change B. Okay, means you are going from here to here. See, when you are changing B, everything else you are keeping same. Then basically you are going from here to here. Okay, if B is dummy, then what should happen? If B is dummy, then these should be same, these should be same, these should be same, these should be same. If B is dummy, yes or no? If B is dummy, then these should be same, these should be same, these should be same, and these should be same. Because you are changing B. Here you have B, here you have B bar. Okay, so can B be dummy? The answer is no. The answer is no because here you have 0, here you have 1. Okay, you can notice here you have 0 and this is your ABC bar, and you can notice this is A, so this is your A bar, B, C bar, and what is this? This is A bar, B bar, C bar. Okay, so finally you can notice that B also cannot be dummy. Is this clear? So remember what I am saying. See, B is dummy. I can say B is a dummy when it will happen. B is a dummy if this happens, these must be same, these must be same, these must be same, these must be same. Okay, so if B is dummy, then this should happen, then this should happen, correct? This should happen, but this is not happening. See, here you can do the don't care, you can change. Remember, don't care you can use as per your choice. Whatever you want you can do with the don't care. Okay, so don't care you can choose according to your choice. But what I'm saying, if B is dummy, then if B is dummy, then these must be same, these two must be same. Okay, these two must be same, these two must be same, these two must be same, and these two must be same. But you can notice here already 0 is there, here already 1 is there. Okay, so this is the contradiction. Okay, so this is not possible. So this is, you can notice, this is a contradiction. So B is not dummy. Similarly, if A is dummy, then what should happen? If A is dummy, then what should happen? Similarly, I can say if A is dummy. Remember, this is the area of A, this is the area of A bar. Okay, if A is dummy, then what should happen? Then this should be same as this. Remember, this must be same as this. I can say this must be same as this. Next, this must be same as this. Okay, similarly, I can say that this must be same as this. Okay, I can say that this must be same as this, and I can say that, okay, that I can say this must be same as this, and you can make them. Okay, you can do it. Already this is fine, this is 0, this is 0. So yes, A can be dummy. If A is dummy, then this would happen. I hope this is clear. So what this question is asking, look at this question. The question is asking that total 8 functions, there are total 8 functions who have this K map. Because there are don't cares, you can remember, you can choose don't care. You can keep the don't care 0 or 1 as per your choice. Okay, you can make them 0, you can make them 1. Don't care is like a joker. You can use it as per your choice. Okay, if you want 0, if you want to make it 0, make it 0. If you want to make it 1, make it 1. So you can use don't care as per your choice. Now this question is saying that this K map, okay, total 3 don't care are there. It means total 8 functions are there. And from these 8 functions, find a function which is of 2 variables. Find a function which is of 2 variables. This is what this is saying. Total 8 functions are there. Find a function which is 2 variables. So tell me, which variable is possible to be dummy? Only one variable is possible to be dummy, that is variable, which variable A. Only variable A can be dummy. So basically this question A is asking that make the variable A dummy. Did you understand this? Please tell me. So this option A, what this option A is asking, this is asking, okay, please understand, this is very simple and very nice question. This is a very nice question. What this question is saying, that total 8 functions are there, but make sure that okay, find a function which is of 2 variables. Find a function. Okay, so in this we have to find f1 which is of 2 variables. F1 of 2 variables means one variable is dummy, one variable is useless. This simply means one variable is useless. And which variable can be useless? Which variable is useless? Which variable you can make useless? The only possibility is A. Only possible variable is A. Only possible is A. This A you can make don't care. This A you can make. Okay, so this is the question. So finally, just make A dummy. Make the A variable dummy. So make the A variable dummy. You want F1, okay, where A is dummy. Where A is a dummy, where variable A is dummy. So because variable A is dummy, it simply means that these two must be same. These two must be same. This is already 1, so this must be 1. This must be 1. Okay. and these two must be same. These two must be same. So this is already 1. So this should be 1. This should be 1. And these two must be same. These two must be same. So this is already 1. So this will be 1. And this is 0. This is 0. This is what the question is asking. So what is F1? Tell me. What is F1? From here, what is F1? So this is the K-map. You can convert this K-map into the standard K-map if you want. But you can write the equation directly also. What is this F1? You can write the equation directly also. See, F1 is, I can say B bar, or see, F1 is B bar. If you notice, this is B bar. Okay, without converting. See, this is not the standard K-map. This is not a standard K-map, but you can very easily see that, okay, when this is the B bar. This is the B bar. And what is this? Can anyone tell me? This is C. Okay, this is C. So the final answer will be B bar or C. You can notice here A is dummy. Can you notice? Notice A is dummy. So tell me, did you understand this question? Like, did you find this question nice? This when I found this question, it became my favorite question. Like, okay, this is a very nice question on K-map. And this question is asking that a K-map is given to you. There are don't cares. So it simply means, let me explain. Okay, please focus here. Please focus on my explanation. So what I'm saying, see, okay, let me explain this. So this K-map is given to you. In this K-map, there are 3 don't cares. It means that 8 functions are possible. You can write total 8 functions. Total 8 functions you can write. From those 8 functions, you find that function where one variable is dummy. This is your question number A. Okay, your question number A is this question number A on your screen. This is saying that from those 8 functions, you find that function where one variable is dummy. That function you find which is a function of 2 variables, I can say. Okay, means one variable is dummy. And you can notice that in all the 8 functions, whatever 8 function you take, in all the 8 function, C cannot be dummy. B cannot be dummy. All the 8 function you take, okay, after the class is over, after this video, after this session is over, you check it out. Okay, total 8 functions are there. In all these 8 functions, you can check it out. C can never be dummy. Okay, B can never be dummy. This is what we have seen. You cannot make B dummy. You cannot make C dummy. So the only choice is A. You can make A dummy. Okay, so like this. So finally, the question is saying, the question number A, okay, the first question is asking, okay, make A dummy. So to make A dummy, we are making A dummy, and then we are finding the equation of F, that will be B bar or C. Tell me, is this clear to everyone? So this question is very easy if you work it out yourself. My suggestion is you work it out yourself and you can watch the video solution again. If you did not understand, then this is my suggestion, please do it. Okay, so if you have any doubt, okay, did not get, did not understand, if you did not understand, then do it yourself. Because when you do it yourself, then you can very easily understand. Okay, so work it out. Work it out. This is the first thing. And the second thing, after you work it out, the second thing is, okay, watch the video again. Watch the video again after working out. Remember, first you work it out. First you work it out, and then if you do not get, then watch the video again. Okay, if you have any doubt, then you can comment. Okay, so on the video you can comment if you have any doubt. Comment after these two, after step 1, 2. This question is not hard. This is a very simple question, but very nice question. How many of you understood this? Like, can you say yes? If you understood this question, can you say yes? So that I get to know, okay, how many of you got this? Like, what this question is asking, what this question is saying. Did you understand that question? Total 8 functions are there. Okay, find a function from those 8. Total 8 are there. Out of those 8 functions, you find that function where one variable is dummy. Okay, so this is the question number A. Now let's see the question number B. The question number B is saying that having 4 minterms. Okay, F2 having 4 minterms means having 4 true minterms. Okay, you find a function which has 4 minterms, and you remember by default when they are saying f2 has 4 minterms, it simply means that they are talking about true minterms. Okay, so there should be 4 true minterms. So let's see this question. So what will be the answer for this one? For B, in the B we are asking f2, the question is asking f2, and in this f2 it must have 4 minterms. Okay, with 4 minterms. And I told you in the class that when they tell you about minterms, by default they are talking about the true minterms. Okay, so this type of function we want to find which has 4 minterms. Already these are the true minterms. See, already these are 111. So already these are 111. Now what should happen? Now the question is asking that, okay, one more. Okay, there should be 4, not more than 4, and minimized expression and minimum expression, and also a minimum expression. So how will you do this? We want minimum expression of a function, minimum expression of a function with 4 minterms. So how will you do this? Tell me. Which of them, which only one of them we can make one. Only one of them we can make one. Okay. There are total 3, don't care. There are 3, don't care, but only one of them we can make one. Because the question is saying that you must have 4 minterms. Not more than 4, not less than 4. You must have 4 minterms. So one of them we can make one. Which should I make one? Tell me. One of them I can make one. Which should I make one? Which should I make one? One of them I can make one. Should I make this one? Like, okay, should I do this? If I do this, okay, I make this one, these 0. These 0. Is this, will this give me minimized expression? If I do this, will I get minimized expression with this? Or should I do this? Like, okay, or should I make this one? Or should I make this one? Which should I do? Or should I make this one? This one? Or should I make this one? So which one should I do? Which will give me the minimized expression? Here, what expression I will get? See, if I make this one, then what expression I am going to get? You can check it out. Here the expression that you will get. Here the expression you will get is, okay, see, this is not the standard K-map, if you notice. Okay, so always it is good that you convert this into standard K-map. This is not the standard K-map, so you can check it out. This K-map is not standard. Okay, so here I can say that actually, but without converting also you can write. See, either you can convert into standard K-map, without converting also you can write. What is this? Here you can notice, here C is 1. In this area, C is 1, B is 1. In this area, C is 1, B is 1. In this area, okay, in this area, C is 1, B is 1. In this area, what is happening? In this area, A is 0. In this area, A is 0 and B is 0. Okay, so the final here the function will be A bar, B bar or BC. Here you will get this function A bar, B bar or BC. Here which function you will get? If you make this one, then which function you will make? Which function you will get here? So here you can make basically, okay, you can do like this. So you can make, okay, what this will give you? What this will give you? This is the area of A bar and the area of B bar. This is the area of A bar, B bar. This is going to give you A bar, B bar. And what this will give you? This will give you A. What this will give you? This will give you, this is the area of A and area of C. Area of A comma C. So final your expression will be AC or A bar, B bar. And if you do like this, then what will be your expression? This will be what? Okay, so this will be what? This will be, this is the area of A bar, the area of A bar comma B bar. This is the area of A bar comma B bar. Okay, this is the area of, this is the area of A, B, C, and this is the, and what is this one? And what is this one? sorry, this one, like this you can do. Okay, like this you can do. So if you do this, then what you will get, this is in the area of C bar and B bar. Okay, so like this you can do. So your final expression, what that will be, that will be A bar, B bar, B bar, C bar, or A, B, C. So which expression is minimum? So minimum expression is, I can say either F2 will be this or F2 will be this. Okay, so two minimum expression are possible for this question. For this question F2, for F2 there are two answers. One answer is this and another answer is this one. Okay, so there are two answers for F2. This is not minimized. Here you, okay, this is not minimized. So definitely this is not F2, not minimized. So okay, so this is, I can say this is not the answer because the question is asking for minimized. Okay, so I can say answer will be this and this. This is not, this is a big expression. This is not minimum. I can say this is not a minimum. This is not minimum F2. Let's see the next question. So, okay, so this question number 2 we have done. Next, the question is saying, the next question, F3 having two prime implicants. F3 having two prime implicants. Okay, so here having two prime implicant, you must have two prime implicant, you must have. Okay, so if you have two prime implicant, then what you should do? Remember, you must have two prime implicant. So this is the question number F3 having two prime implicants. So you must have two prime implicant. Already remember, this is one, this is one, this is one. Okay, so you must have two prime implicant. Then what I can do? So there are four minterms, right? You can see here total four minterms we have created. Debanjan, total four minterms we have created for this F2. For this question number F2, total four minterms we have created. You can notice here also four minterms, here also four minterms, here also four minterms. We have created four minterms. Next, the question number F3, this is asking it should have 2 pi and minimum expression. 2 pi and the expression must be minimum. Okay, minimum expression and 2 pi. There must be 2 pi, but the expression must be minimum. So what should I do? 2 pi and minimum expression. What should I do? Okay, so here for this I can make this one. Okay, like this I can do, very simple, like this I can do. Okay, if I do like this, then you can notice I will get 2 pi. I will get 2 pi. Definitely I will get 2 pi. I will get this one and this one. Okay, so this one is what, this is your B bar, and this one is what, this is C. So your F3, so your F3 will be C or B bar. This will be your F3. Nikhil is asking, sir, we don't we need to convert it to standard K-map? Nikhil, yes. See, you can convert into the standard K-map, but with practice, you can handle the direct K-map also. With practice, if you do enough practice, then you can handle the direct K-map also. But if you have any doubt, okay, please convert into standard K-map. I am doing directly because of practice. Okay, but if you have any doubt, please convert into standard K-map. Then you solve it. All these questions, okay, in this question first you convert into standard K-map and then you solve the question. Is this clear, Nikhil? The next question, F4 having a prime implicant that cannot appear in the minimum SOP. So this option number D, you must have a prime implicant that cannot appear in minimum SOP. Okay, one prime implicant does not, okay, a prime implicant does not, a PI not in minimum SOP. Now what should I do? A PI should not be in minimum SOP. Now for this, what should I do? For this one, what should I do? A pi not in minimum SOP. So for this, what can I do? You can make this one. Notice. If you make this one, if you make this one, okay, and if you make them 0 0, if you make this one, then what will happen? How many pi? Okay, you can check. So okay, there will be this one, there will be this one, and there will be this one. Okay, so one pi will not appear in the one pi will not appear. So this f4 is same as f2. This f4, this will be same as your f2. You can check. Okay, so this f4 I can say there is one pi which will not appear in the k-map. So it will be area of AC or area of B bar A bar. Okay, so this will be your f4. I hope all these questions are clear. Please let me know, do you have any doubt? If you have any doubt, work it out, watch the video again, and if you have any doubt, you can comment. These questions are very nice. Remember one more thing. Okay, remember one more thing. Always convert into standard k-map. Okay, if you don't want to make mistake. Okay, two, if you don't want to make mistake, then in the beginning you should have converted. If you don't want to make mistake, then always convert into standard k-map if you don't want to make mistake. This is my suggestion that, see, I did directly, I am doing directly, but you should, okay, you, okay, if you don't want to make mistake, always, this is my suggestion for everyone, always convert into standard k-map, into standard k-map. Okay, so this is my suggestion for everyone, always convert into standard k-map. So like this question, as soon as you see this question, just convert it into standard k-map. So this question, when you see, just make it into standard k-map. You can make it like this. We have already seen how to make this into standard k-map, I told you. Okay, so the standard k-map you can create. So like this, B, A, comma, C. Okay, so like this you can create. This is the area of A, this is the area of C, and this is the area of B. So you can convert into like this. So it will be, I can say, so what will be the standard k-map? The standard k-map will be like this. So this is the area of A. So this will be 0, this will be don't care, this will be 0, this will be don't care, and next this will be don't care, this will be don't care, and next here you can notice that, so this will be 0, this will be, sorry, this will be 0, this will be don't care, and next you can notice this will be 1, this will be 1. Okay, so first you convert this into standard k-map. Now on this you solve all the questions, please. Okay, on this you solve all the questions. Now you have this one. Okay, now you forget about this. For this one you solve all these questions from f1 to f4. All these questions you solve on this k-map. Okay, on this k-map solve. This is your homework. On this k-map, on this standard k-map, solve f1 to f4. Solve all the questions f1 to f4. Is this clear, Nikhil? Please tell me. If anyone has any doubt, okay, then first you convert into standard k-map. Now we have the standard k-map. This is your standard k-map. On this standard k-map, okay, what to do? You solve f1 to f4. Can I give this as a homework? See, we have, okay, answer you already have. All the answers you already have, but this is simple that, okay, on this k-map you have to solve the question. What this question f4 is asking? I am explaining f4 again. So students are asking for f1, f4. So let's see the f4. First you make the k-map. This is the k-map. Okay, so this is the k-map. So in this k-map you can notice this is A, C, B. And what is the k-map? 1, 1, don't care, don't care. 0, don't care. 0, don't care. Sorry. So there is some mistake here. So there is some mistake in this k-map. Okay, when you are converting it into standard k-map, then in this row of B bar, you have to, okay, in the row of A, in the row of B, so that will be 0, 0, and next it will be, so this is 1 actually, sorry, this is 1, so this is 1. Okay, so this one is 1, remember this one is 1, this is 1, so this is 1 and this is 0. Now on this, what this F4 is saying, so this is your K map. Please, please understand, I am explaining, please understand, focus here, I am explaining again. This is the given K map. Okay, remember this is your given function. This is your given function. Total how many don't cares are there? Tell me number of don't cares. What is the number of don't cares? Total 3 don't cares are there. I am again explaining F4. Please understand. Total number of don't cares is 3. It simply means that this is a class of function. It simply means this is a family of function, or I can say class of functions. This is a class of functions. Okay, how many functions? 2 power 3. That means total 8 functions are there. So this K map represents total 8 function. And what this F4 is saying? This F4 is saying that find a function. Okay, total 8 functions are there. Find a function in which in which you have a prime implicant which is not in minimum SOP. Okay, so out of 8 functions, find one in which in which a pi doesn't appear doesn't appear in minimum SOP. This is your question number 4. Is this clear? Did you understand this? Tell me. This is your question number 4. So let me change. Okay, so out of total 8 functions are there. Out of those 8 functions, find a function in which there is a pi. Again, see, 3 don't cares are there, means total 8 functions are there. You can think like this. Total 8 people are there. Okay, total 8 people. From those 8 people, you have to find that person. You have to find that person which has a pi, which has a prime implicant, which does not appear in the minimum SOP. Okay, this type of person you have to find. This is what question F4 is saying. What question F1 is saying? The question F1 is saying that you have to find, what was question F1? Yeah, in F1 you have to find a person. Total 8 people are there. From those 8 people, you have to find a person which has only 2 variables, means which has one variable, dummy variable. Similarly, total 8 people are there. You have to find one person. You have to in F2 you have to find one person which has 4 minterms. Okay, in F3 there are total 8 people. From those 8 people, you have to find that person which has 2 prime implicant. That is your F3. Okay, so total 8 people are there. Those 8 people, they can have different number of prime implicant. Okay, they can have different number of minterms, true minterms, right? So in F2 we have to find that person which has 4 minterms. In F3 we have to find that function which has 2 prime implicant. In F4 we have to find that function which has uh, a prime implicant which is not appearing in the minimum SOP. And in F1 we have to find that function which has one dummy variable. So these are the 4 questions, F1 to F4. Now did you understand? Please tell me, did you understand the meaning of these questions? Always convert into standard truth table. So in the question, when you see the question, the the K-map is given to you. Okay, before solving the question from F1 to F4, okay, don't solve any question. First, to directly convert the K-map into standard K-map. Once you have your standard K-map, then you solve all the 4 questions from F1 to F4. It is very easy. And these questions are very nice. Okay. So now let's see this one. Now did you understand the explanation? So let's see finally. Okay, so F4 we have to find. And F4 means we have to find a function which have a minimum. Okay, so for this F4, we must have a function. So tell me, for F4, can I do this? Just tell me this one. The question that I am asking. For F4, for the question for F4, can I do this? For F4, can I do, like, can I replace them with 1? Can I do this? Can I replace them with 1? Tell me, can I do this? Will it satisfy F4? Can I do this? No, it will not satisfy F4. because if you do this, there are two pi. If you do this, there are two pi. Okay, there are two pi. In this situation there are two pi, and both will appear, you can notice both will appear in minimum SOP. If you do this, then both will appear in minimum SOP. So this is, so definitely this is not correct. This is not correct for F4. This is not correct setting for F4. Definitely this is not correct setting for F4. Okay, this is not correct setting for F4. Next, next you tell me, can I do this? Like, okay, if I do this one, for example, these I write like this, 0, 1, 0. Will it work? Will it work? Will this work? In this, do we have a function? Do we have a PI which does not appear in the minimum SOP? Will it work? Do we have a PI which does not appear? See, this is a PI. This is a PI. Another PI is this. This is another PI. Another PI is this. Okay, another PI is this. And another PI is this. And another PI is this. So this also will not satisfy. This is another PI. There are three PI and all are EPI. All are EPI. So all appear, okay, all will appear in minimum SOP. All will appear in minimum SOP. So this setting is also not correct. Okay, not correct setting for F4. Not correct setting for F4. This is the meaning. Okay, so tell me, can I do this? Like, okay, instead of these, can I do this? For example, can I make it 1 and I can make them 0, 0? Can I do this? Will it satisfy? Will it satisfy? Yes, now you have this PI. You can notice this is a PI. You can also notice this is a PI. And you can notice this is also a PI. Okay, you can notice that this is also a PI. But this PI will not appear. This will not appear in a minimum SOP. This will not appear in minimum SOP. So this setting is correct. This setting is correct for F4. This setting is correct for F4. Okay, so finally, and this will also give you minimum expression. So what F4 you will get? So the F4 that you are going to get, that is AC or A bar B bar. Okay, so you will get this AC or A bar B bar. So this is what you will get, and this is the minimum. Like whatever you do, if you do something else, then whatever you do, see, you can do like this also. This will also work. If you do like this, this will also work. This will also work. If you do like this, okay, so this will also work. And tell me, if I do, for example, if I do like this, will it work? If I do like this, will it work? See, this will also work because this PI will not appear. This PI will not appear in this PI, not in minimum SOP. So this is also correct answer. But tell me, this setting, will this setting work? Will this setting work? Is this setting going to work? In this setting, this is the PI. In this setting, you can notice that this is the PI. In this setting, this is the PI. And this is another PI. So this setting will not work. Both are EPI. They both are EPI. Both of them are EPI. So this setting is not correct. This is not correct setting. For F4, this is not correct setting. So can you give me some other setting? Like, okay, so for example, if I put all zeros, will this setting work? Will this setting work? If I put all zeros, will this setting work? If I put all zeros, now this is a PI, this is a PI. Again, both PI are EPI. This is a PI, this is a PI, and you can notice both are EPI. Both are EPI. So this setting will also not work. So this is the idea. Did you understand the idea of all these questions? Okay. So like this. So we have done, and so this question we have done a lot of time we have spent in this question, but see what you have found. Now your understanding of K-map, maybe it has improved, always convert into standard K-map before solving the question. Always, okay, this is a note I want to tell you. Before solving any question, before solving any question of K-map, before solving any question of K-map, always convert into standard K-map. Always convert into standard K-map. Okay, always convert into standard K-map. So all these four questions that you have, you can solve these questions. Again, you can try these questions. Okay, all these four questions, try. Okay, what you do after this video is over, after this session is over, what you do, first you convert this into standard K-map. Okay, after converting this into standard K-map, then you solve all these four questions. Okay, each of them you solve. In this video you have the answer, already the answer is available. Okay, so you don't have to worry about it. So you solve this question. First you convert into standard K-map, then you solve all these four questions from F1 to F4, you solve. Again you solve. Okay, so this is your homework. You can write your answer in the comment. This is your homework on the standard previous question. Previous question solve. Okay, previous question F1 to F4 solve. Okay, solve on standard K-map. Okay, so this is the homework that I'm giving to you. Students are asking for PDF. Yes, PDF will be available in the Digital Logic 2023 course. You can check it out. Okay, on the Go Classes website in the Digital Logic 2023 course. Within that course, okay, all the PDFs will be available. All these annotated lecture notes will be available there. Okay, so if you want the annotated lecture notes, so you can just see the Digital Logic 2023 course. You can see on the Go Classes website. Okay, there you will find it. Okay, so I think so. Let's actually, I want to finish this also. So let's finish this in the next session. Okay, this is enough for today. Already this session we have, I think, for this one question a lot of time we have spent. Okay, so this is enough for today. The next session we will have maybe on Wednesday. Okay, so we can have, so basically I want to discuss this, some questions of multiplexer I want to discuss. Very nice questions are there. So like this question, so this circuit is given to you and you have to analyze this circuit. So this type of questions I want to discuss. Can you analyze a given circuit? Okay, so this type of around 5 to 6 questions we will discuss in the Wednesday session. Okay, on the Wednesday we will have session number 4. Is this clear? Session number 4 we will have on standard question session. On Wednesday we will have, and in that session we will solve this type of questions. Can you analyze a circuit? Some circuit I will give to you, like this circuit I will give, some other circuit I will give. Okay, like for example you can notice, like this circuit I will give. Okay, so these things I will ask. So this question actually you can take as a homework. Okay, and you can answer your, you can find your, you can tell your answer in the comment. You can tell what is the answer, like option A, option B, option C, option D, which answer is correct. Okay, so you can put your answer in the comment. So take this question as a homework. Okay, this question, this question, this is a very nice question from a standard university. Okay, standard question this is. In this question you can notice decoder is given to you. This is a 2 by 4 decoder, this is a 2 by 4 decoder, and this is the OR gate, and this function we have, this function f we have, and the question is asking, okay, what is this function f? So what you do, you solve this question. In the next session I will discuss. Okay, in the next session I will discuss this question, but before that what you do, you solve this question and you put your answer in the comment. But remember, on the Wednesday we will have this session and we will solve a lot of questions on Wednesday. Okay, 5 6 questions of analysis of circuit we will do. Okay, thank you everyone. If anyone has any doubt you can ask. So session number 4 is on Wednesday. Please tell me, do you have any doubt? Is there any doubt, anyone? So this type of session we will have many session, we will have this type of sessions. Okay, all these sessions you can uh, all these sessions you can join. Remember, in all these sessions I will take only the tricky questions. Okay, like basically these sessions are going to improve your knowledge gap. Like, okay, you are thinking, I know K-map, okay, I can solve K-map, I can minimize K-map, okay, I can handle don't cares. But you can notice in this Cambridge University question there are 4 questions. Okay, and in all those 4 questions they are not asking minimized SOP. See, they are asking different type of function. Total 8 functions are possible. From those 8 functions they are asking some minimized expression of particular functions. Are you getting my point? Minimized expression of particular function, like minimized expression of function which has 2 prime implicant, minimized expression of function which has a prime implicant which does not appear in the minimum SOP. Okay, so like that, minimized SOP of a function which has 4 min terms. So this type of questions are there. Okay, so all these standard sessions you can watch the previous standard sessions. This is the standard session 3 part B. Okay, you can see the part 1 also. This is the part 2 of the standard session 3. Okay, and there will, in the future also, there will be this type of session. In every standard question session your knowledge gap, okay, that we will fill. I can guarantee that. Okay, if you watch all these sessions, then many concepts will clear. They will become very clear, I can say. Like, it's like suddenly you will have some light on your concepts. Okay, all the gaps, those will be filled. Okay, so thank you everyone, thank you so much. Okay, and definitely your analytical skills will improve. You know, this problem solving skills, some people call it problem solving skills, this will improve. And this will not improve in one day, but slowly this will improve. Okay, by the end of this year, definitely whatever new question comes to you, okay, if someone gives you a new question, then definitely you will be able to solve it. Okay, so we will improve your analytical skills so that you can tackle any problem, you can handle any question. In the gate exam, whether they ask you hard paper, easy paper, moderate paper, any type of paper comes, like gate 2021, gate 2022, okay, 21-22, this type of paper comes, or easy paper comes like 2019, you know, 2019, 2020, so those papers are easy. 21-22, those papers are hard. Whatever gate paper comes in your exam, okay, you will be able to solve the questions. Okay, and for that you have to improve your problem solving skills, and that problem solving skills you can improve slowly with go classes. Okay, so if anyone has any doubt, you can ask in the comments, and you can join our future sessions also. And also, if you want to study all the concepts, every subject, every concept, if you want to understand in the best manner, with proof, without rote learning, without by hearting, if you want to understand every concept, then you can join go classes. Okay, so visit go classes website, there you can join our go classes 2023 course, you can join 2024 course. Okay, or if you want to join a particular subject, like if you want to join our, for example, computer organization, like operating system, theory of computation, a particular subject, if you want to enroll, that also you can do on the go classes website. Okay, and also go classes and gate overflow test series, this combined test series you take, attempt the test. Every test, in every test there are some new questions, some new terminology we have defined. Okay, those questions will definitely improve your analytical skills. Okay, target of test series, the what is the point of test series? Improvement of knowledge. Okay, how are you performing in the test does not matter. Okay, like for example, from 50 you are getting 20 marks, it does not matter. Marks in the test series does not matter. What matters, how much are you learning? Okay, so learning is important. Your learning should improve, I can say, your knowledge should improve, and that will definitely happen with the go classes and gate overflow test series. So my suggestion is that after this, after today, okay, or maybe today, you can attempt go classes Boolean algebra test number 1. Okay, so just attempt it. In that test, definitely you will find some very nice questions you will find. Okay, so thank you everyone, thank you so much. Okay, so see you on Wednesday in the next session. The next session we will have on the Wednesday, session number 4. In that next session we will solve questions related to decoder, multiplexer, encoder, encoder, demultiplexer. Okay, decoder, encoder, multiplexer, demultiplexer, these 4 topics. A lot of questions we will take. Okay, around 10 questions I will take. Okay, all these questions will be standard, very nice questions.